All right. Hi there, guys. So this lecture video is going to be another generics example. This time we're going to be talking about enforcing a generic type to implement or extend multiple interfaces and/or a class. So if we look at the lecture slides here, the very last lecture slide in the generics example says we can require that a generic type inherits from or implements any class, abstract class, and/or interface. Remember that you can inherit from only one class, but you can implement multiple interfaces. And so this is the syntax for doing so. Class, foo, the generic angle brackets, generic type E, extends some class, and so the class will always come first if you are doing a class. And then the ampersand, some interface, ampersand, some other interface, etc. It is weird syntax for generic types, but we don't really have a choice in that because we didn't design the language. So let's go ahead and look at an example. So here's my main. Should be nothing new to you guys, and then here's my generic class. So we'll go ahead and make it generic with type E in this case. This is kind of the usual setup for now. So we'll have an input or a variable, classified variable called item of type E. We'll go ahead and specify a constructor, my generic class E. We'll call this item, and this dot item equals item. Cool. And that's about all we can do right now, because like we've previously talked about, we don't have any methods to call. If we try to do anything, for example, if we just said item dot, right, and we can see the only things that get auto-generated are the methods available to us from the object class, but that's useless. Now, you might have watched the comparable interface video, and if you did, okay, well, enforcing an interface on a generic type is a way to suddenly have access to methods. So the very first thing I want to be able to do is print my variable. That's what I want to be able to do. And I want something like this. Public void print, and I want to be able to call item.print. Obviously, item.print doesn't exist yet, but we can enforce it to exist. So if I'm the designer of this class here, I can say, well, I want item to be able to print. So I'm going to say E extends, and in this case I'm going to make up a class. I'm going to call it printable. Now there already exists a printable class. That's actually not the one I want to use. I'll probably call it printable2. And so yeah, of course, printable2 doesn't exist. I need to make it. So I'm going to go over here and create, it says new Java class, but you can actually specify interface. And I'm going to call it printable2. And just as an aside, if you had said, make class printable2, you could have just interchanged the class here for interface, and that would have worked fine as well. And so what did we say we wanted our printable2 interface to include? If you recall, it's a print method. So let's say void print. But remember, an interface, right, you don't implement any code. All you're saying is whoever implements this interface must implement this method. So this is a use of an interface. Now, notice, great, print works. Or we think it works. Obviously, we don't have anything that implements this interface just yet. So if we go to main here, and we try to use the my generic class, and we're going to specify a type. Well, what type do we specify? You could do something like this. MGC equals new my generic class. But the issue is we have to be able to input a printable to object into the constructor, and we don't have that, nor can we create that. If you recall, let's just call this P2 equals new printable to. This is some fancy stuff that you don't need to look at. It gets mad at you, right? And that's because printable to is abstract. It's an interface. It cannot be instantiated. So what we really need is a class that implements the printable to interface. And so we'll go ahead and make that. We'll say new class. We're going to go ahead and just call this my class. And it needs to implement the printable to interface. Now, just to confuse you more, right? Remember, we used extends for generics, so let's try and use it now. But it's going to get mad at you. It says basically, my class must either be declared abstract or implement the abstract method print in printable to. So we'll implement the methods. But it still gets mad at you. No interface expected here. What that's saying is, this is an interface, but you're using the extends keyword. And in this particular instance, remember, we implement an interface. Yes, it's all sorts of confusing. I don't know why Java did it this way, but we implement the interface when we're not dealing with generics. And so here's this print method that we specified. And what is it we want to print? Well, let's just start with system.out.println, I don't know, hello world. Okay, great. So we now have something that's implementing this interface. And so I can leave printable to here, or I could say, my class. Either of those work. I'll do my class. We'll call it nc equals new my class. And the input, or our constructor for my generic class, is still missing an input parameter. So in this case, MC. So remember, this is basically saying E, in this case, will get replaced with my class. And so when we look at in the my generic class, what is item.print doing? Well, it's doing what I've specified in the my class. So in this case, printing hello world. So if we go ahead and run this, or first let's go ahead and print. So mgc.print, it should print hello world. Great. So let's go ahead and make it a little more complex. Let's extend a class. So let's see. I'm going to want to do something like this. Public int get value. And I want to return item.value. Well, item obviously doesn't have a variable called value. So let's enforce the generic type E to have a variable called value. So in this case, if you remember, the syntax was ampersand, so ampersand. In this case, I'm going to call the class valuable. Valuable. And of course it gets mad at us because valuable cannot resolve symbol valuable. That basically means, oh, we don't know what that is. So that's because we haven't created the valuable class yet. Let's go ahead and do that. Say valuable. In valuable, it's going to have a int value. We'll specify constructor, public, oops. If I could type right, valuable, int value, this dot value equals value. Great. And this is all we'll do for now. If we go back here, Okay, great. Although it's strange, we still have value here is having an issue, and valuable up at the top here is having an issue. We'll look at this one first. It says interface expected here. So why is that? Well, if you recall, if we look at the syntax here, notice how in the slide, E extends some class and then some interface and another interface. Well, that's because the ordering for generics, you must first extend the class and then interfaces follow. So really what needs to happen here is you need to swap these. And conveniently, my IDE actually gives me a useful suggestion here. Move bound valuable to the beginning of the bounds list of type parameter E. What this means is swap them. And so they're swapped. Problem is solved, and wow, if you look at that, it actually solved my other error. So yeah, E now has, if we look at it, item, which is of type E, has a value and also a print method. So we're enforcing our generic type to have something useful to it. If we go back to our main here, of course, what's the issue here? My class is not within its bound, should extend valuable. So of course I can go to the my class and extend valuable, but also my IDE conveniently gives me this option, make my class extend valuable. So I'll click that, my class. Oh, look at that, extends valuable. Basically what it did, if you remember previously, it was my class implements printable2, and now my class extends valuable and implements printable2. So why does it matter to us? There is no default constructor in valuable. So, you can see that there's an option here, and I can click it, and it'll solve my problem for me. But I actually want to address this. If you recall, the valuable class does not have a default constructor. So while every class starts off with a default constructor, thanks to Java, once you've given your own constructor, the default constructor, one with no input arguments, is no longer there for you. And so valuable doesn't have a default constructor. In order to create a valuable object, you must input a value of type int. And so basically that's what this is saying here, is there is no default constructor, and so you're going to have to use the super keyword. And so it looks something like this. Public my class. You will want something similar to the valuable interface, or class. And this is what it's expecting. If I could type correctly, that'd be swell. All right, cool. So this is what it's expecting. You need to call your superclass's constructor appropriately, since the superclass does not have a default constructor. What is this doing? Well, super value calls your superclass, or the valuable class's constructor, giving it a value of value. In this case, this is setting the internal variable value. Okay, so I think we're good. If we go back to my generic class, main, we'll see, okay, my class is missing an input parameter. We'll give it 5. And it looks like everything is good. So we'll do mgc.print, and then the other method we specified in my generic class is getValue. So we'll go ahead and print system.out.println mgc.getValue. So basically this should be printing 5. There you go, hello world, and then 5. And so you can see enforcing a generic type to adhere itself to some sort of class and/or interface can be extremely useful. It gives you a lot more functionality when working with generic types. And this concludes this example of type enforcement for generic types.